A quadratic polynomial of the form x squared plus bx plus c is one of the easiest polynomials to factor when the coefficients b and c are integers. If such polynomial can be factored, then the factorization is of the form x plus p times x plus q, where p and q have to satisfy two conditions. P times q has to be c and p plus q has to be b. Let's look at the example. We want to factor polynomial x squared plus 5x plus 6. Here the b is equal 5 and the c is equal 6. So what we want is we want two numbers p and q such that p times q is c or 6 and p plus q is equal 5. Often we can figure out what those numbers are pretty quickly, and in here the value of p can be chosen to be 2 and the value of q can be chosen to be 3. It doesn't matter which one is which because the value of p and q are symmetric. So we can say now that the polynomial x squared plus 5x plus 6 factors as x plus p, which is 2x plus 3. We can easily check that this factorization is correct by multiplying. Now, one remark that I would like to make here, it is not always easy to find the numbers p and q. For example, if I take x squared minus 2 polynomial, here b is equal 0, here c is equal -2, and I'm looking for two numbers for that when multiplied give me -2 and when added give me 0. This polynomial has the factorization x minus square root of 2 and x plus square root of 2. We can easily check that the product of those p and q's is -2 and the sum is equal 0. So not always the numbers p and q are going to be integers. If they are, we'll say that the polynomial factors of the integers. If they are not, sometimes we say that our polynomial is prime with respect to integers.